What's going on, Algebros? In this video, I'm going to show you how you can factor a polynomial function using its zeros. What allows us to do this is a fact related to the ring of results we looked at in the previous section of Chapter 5. It says that if r is a real zero, then x minus that real zero is a factor of the polynomial function f of x. Stated symbolically, if r is a real zero, then the function f of x starts to break down into a factored form where one of the factors is x minus that real zero, and what remains after you factor out x minus r is going to be a quotient polynomial, which we get from synthetic division. And depending on the degree, we might use more and more zeros to continue breaking the quotient polynomial down until we get to a point to where we can fully factor the rest of the polynomial function. So let me illustrate this with an example. It says, let f of x equal x cubed plus 8x squared plus 11x minus 20. And it says here, use the provided zeros to factor f of x. So we're going to want a factored form of f of x, and currently it's in standard form. Now they provide us with three zeros, -5, -4, -1. We can start out with whatever choice of zero we want. Because it states here that these are the zeros, we know that we're going to be able to factor regardless of which zero we choose. So I'm just going to go in order from left to right, and I'll start out by using -5. Now, how do we use a zero to start factoring a polynomial function? Well, what you're going to have to do is some synthetic division with this zero. So I'm going to put -5 in that first half box, and then the coefficients of our dividend, which is our polynomial, to the right of it, 1, 8, 11, and -20. We'll do the synthetic division. And since we know that -5 is a real zero, we should end up with the remainder of 0. So let's see about that. -5 times 1 is -5. Adding down, we get 3. Multiply by -5 again to 3. We get -15. Adding that down, we get -4. And then one more round of multiplication by -5 will give us +20. And lo and behold, adding -20 to +20 gives us a remainder of 0, which makes me so happy I'm going to draw a dabbing emoji. #dab. So we know that -5 is a real zero. That means we can start to write f of x in a factored form where one of the factors is x minus -5. And then to the right of this will be our quotient polynomial. Now our quotient polynomial is going to come from these three numbers. In fact, these will be the coefficients of the quotient polynomial, which, let me remind you that we started out with a degree 3 polynomial, so these will be the coefficients of a degree 2 polynomial. So at this point, a partially factored form of f of x is going to be x plus 5 times x squared plus 3x minus 4. Now, if you're able to factor this quadratic factor by hand, which it looks like we would be able to, then you can kind of drive the problem home by just factoring this quadratic expression, in which case you would have the fully factored form of f of x. In some cases it won't factor by hand, in which case you'll have to use the quadratic formula to help you figure out what the zeros are, in which case you could turn those into factors. Or if you want to use one of the other zeros from the list to break down this quadratic factor, that works as well. And that's what I'd like to do. I'm going to roll with -4 next. And by that I mean I'm going to do synthetic division with -4, but I'm not going to use the original version of the function. Rather, I'm going to use the quotient. In other words, I'm going to use -4 to break down the quotient polynomial we got from the first round of synthetic division. So the numbers directly to the right of -4 are going to be 1, 3, and -4. Okay, those are the coefficients of our quotient polynomial. Alright, we'll do the synthetic division. We'll drag down the 1, multiply by -4, add down, that's -1, multiply by -4 to give us +4, and we'll add down, and we get a 0 remainder again. Alright, it's probably no surprise as to why we get a 0 remainder. We know that -4 is another 0 of the function f of x. And again, I'm so happy about that. I do a dabbing emoji. So at this phase, we could write our polynomial function as x plus 5. And I'm going to build the factor out of -4. And then we'll have to multiply that by the quotient polynomial we get from this round of synthetic division. Let me first simplify that second factor. Now the quotient polynomial is going to come from these two numbers, and bear in mind that our dividend was a degree 2 polynomial. Therefore, our quotient should be a degree 1. Specifically, it's going to be 1 times x to the first power minus 1. And there's no more factoring to do, and because of that, we're not going to really need to use the 0 of -1. But a quick comment about those zeros is that since they are all zeros of the polynomial function, you don't have to start with -5. You could start with -4. You don't have to use -5 at all. Truth be told, you could use -4 and -1. Your numbers might look a little different than mine, but at the end of the problem, we should have the same factors regardless. So looking at this expression right here, x plus 5, x plus 4, x minus 1, there's no more factoring to do. So here comes our factored form of the polynomial function. And that's all we had to do for this problem. So I'm going to cut the video here. Of course, if you have any questions, let me know. Otherwise, thanks for watching, and I'll see you in the next one.